So, good evening, all of you. Welcome to the last session on our green belt learning. So, this particular session we'll be talking about control phase. In control phase, I want all of you to gain a proper clarity on a very, very important tool known as control chart. Control chart is listed as one of the 7 basic quality control tools. If you know what is a control chart, then developing control plan will become easier job for you, right? So in the outline, a control chart is a tool that can help you to differentiate the variation between common cause and special cause. So what is the purpose of a control chart? It helps you to differentiate whether the variation is a common cause variation or a special cause variation. So if it is a common cause variation, it refers to the nature of the process. It refers to the nature of the process. See, we only developed the process. We only designed the process. So it will definitely have some nature. So as per the design of the process, certain variation is inevitable. You cannot eliminate, right? So those variation are known as common cause variation. Then what is special cause variation? Special cause variation means the source of the variation, the reason for the variation can be assigned to a factor. If you can assign the reason for the variation is known as assignable cause of variation. Any assignable cause of variation is nothing but a special cause variation. All of you understand what I'm telling? So what are the 2 types of variation I'm talking about right now? One is
Special cause and assignable cause.
Very good. Common cause, the other one is special cause. And if you investigate, you can certainly find out the reason for the special cause variation. Even if you investigate, you will not be able to find out any specific reason for the special cause. So just to help you understand, the proper meaning of the common cause and special cause. If I ask all of you to travel using a bike and reach a particular destination, simply assume all of you are starting from the same point and you all have to reach the same destination. All of you are using the same type of vehicle, same route, same destination, same starting point. Do you think all of you will consume the same amount of time to reach the destination?
No.
Definitely no.
No.
And now, what do you think the source of the variation? What could be the source of the variation?
Speed.
Source of the variation, can it be a common cause variation or special cause variation?
Distance.
Both, sir.
It can be both. It can be both. Suppose if the variations are very, very minimal, say for example, Ashim reached the place in 20 minutes and Sadashiv reached the place in 20.1 minute. Mohanarangan reached the place in 19.9 minute. Can you see the variation? How much variation? It's a very minimal variation, yes or no?
Yes, sir.
Even if you
Yes.
drive the bike, you will also experience the such minimal variation. Whenever the variations are very, very minimal, right? That means if your data points are clustering around the central value, the variation can be considered as a common cause variation. Clear?
Yes.
Suppose if 1%, so everybody reaches the destination in 20 minutes, but only 1%, he takes, 35 minutes. Now the average time taken is 20 minutes, but one person alone, he took 35 minutes. Now, how would you like to call this variation? Would you like to call this variation also common cause or a special
No,
cause?
special.
Special.
Special cause.
Special cause. Because now if you actually investigate, ask the person the reason for the variation, he will definitely know, can come out with a reason for the delay in reaching the destination. Yes or no? It could have been some kind of vehicle repair, or it could have been missing the route of the way, or it could have been a heavy unexpected traffic. So what is your understanding now? If the variations are minimal and if the data points are clustering around the average, not moving away from the average, right? Clustering around the average, not moving away from the average, then the source of variation can be called as the common cause variation. Right? The moment you say something is common cause, please understand, you just cannot eliminate. You just cannot eliminate. Even if you investigate, you will not be able to understand. Right? Even if you investigate, you will not be able to understand the reason for the variation. Nobody will be able to explain the reason for the variation. Why? Because it is part and parcel of your process. If all of you write an exam, is that all of you will get the same mark? There will be some variation, isn't it? Plus or minus 1 or 2 marks.
Some variation.
And I cannot, even I cannot explain why, the small variation in the mark happens. If somebody scores very high mark or somebody scores very low mark, probably I can come out with some points, isn't it? So for special cause variation, you can assign a reason. But for common cause, you cannot assign a reason. In any control chart, there will be 3 lines. A center line, and a line above the center line, and a line below the center line. The line above the center line is known as upper control limit. The line below the center line is known as lower control limit. You all know the formula for upper control limit and lower control limit. We have educated you, yes or no? What is the formula for upper control limit? What is the formula for upper control limit? Yes.
Mean plus,
Mean plus
3
3 sigma.
Very
Mean
good.
minus
Mean plus 3
3
sigma is upper control limit. Mean minus 3 sigma is lower control limit.
Lower control limit.
When you say 3 sigma, you should know what is the point you are projecting. What is it an individual data point? Or is it an average? You should know that, right? If it is an individual data point, then the standard deviation is just the sample standard deviation. See, I can simply, collect sample and then plot all the samples as it is. If I just take one sample and then plot that point, then the standard deviation is nothing but standard deviation of your sample. All right. Suppose if you plot the average, every point you plot in a control chart is an average, because your control chart is an average control chart, X bar control chart. If every point is an average, then your control limit will be 3 standard deviation, 3 times 3 standard error away from the center. I'm using another word here. There is standard deviation earlier I used. Now I am using standard error. When the standard error comes into picture, when your points are average, when you are plotting averages, you want to understand how is your average moving, right? For averages, you must use standard error. For individual data points, you must use standard deviation. So this is, a broader idea about the formula for the control limit. But since people can easily undergo the confusion, when we keep explaining all these things in this manner, statisticians have developed formulas. You don't have to think too much. Rather, use the available formula. Automatically, you will locate the control limit perfectly. Sometimes they say it is plus or minus A2 into R bar. Sometimes they will say it is D3 into R bar, D4 into R bar. You remember, so many formulas are there, right? So don't worry. All these formulas are only to help you make the right decision about the control limit. You can locate the control limit correctly. All right, because the sample size, as the sample size varies, it is very difficult for anyone to locate the control limit correctly. So for various sample size, various values, constants are developed, and finally you are locating the control limit. But in general, plus or minus 3 standard deviation from the center can help you to get the control limit. Again, control chart are broadly divided into 2 categories. One set of control charts for continuous data. Another set of control chart for attribute data. You all know what is continuous data, attribute data. Continuous is measurable, attribute is countable. So, if the data is continuous data, sometimes in Minitab we call such data as variable data. In Minitab it is known as variable data. Variable means continuous. So you have 3 control charts for variable data. X bar R chart, X bar S chart, and then IMR chart. So I'm just sharing my whiteboard so that I can write something. So this is how the control chart will look like. This is your center line, upper control limit and lower control, right? So if all the points are lying just inside the control limit, the process is considered to be under statistical control. The process is under a state of statistical control. All right. And this distance will be in general 3 sigma. And this is 3 sigma. And when we say sigma, we actually refer to standard deviation of population. But since most of the time we will not be knowing the standard deviation of population, we can use sample standard deviation. We can use sample standard deviation. Whenever you don't have the value of population standard deviation, then the option is use what is available. Isn't it? Use what is available. You don't have a pen, but you only have a pencil. You can write using the pencil, isn't it? Right? But whenever the population standard deviation is known, you can use it. And similarly, sometimes, just a second, I have to charge my I was writing in the whiteboard. Yeah. So the upper control limit, lower control limit, center line. Okay. And now, particularly when your data is a variable data. Let's say your data is variable. Now, you have to understand your sample size. Sample size is nothing but subgroup size. Sample size is nothing but subgroup size. The subgroup size can be any number from 1 to 25. While plotting a control chart, the subgroup size can be any number from 1 to 25. If the subgroup size is just 1, then you have to go for a chart known as IMR chart, where MR stands for moving range. I is the individual value. Suppose if your subgroup size is less than or equal to 8, 2 to 8, right? In this case, you have to go for X bar R chart. In this case, you should go for X bar R chart. If it is more than 8, then you should go for X bar S chart. Clear, all of you? How many charts I introduced? IMR chart, X bar R chart, and then X bar S chart. When all these charts you will be using? When your data is variable. Again, once the data is variable, you should know what is your sample size or the subgroup size. For a sample size of 12, tell me which control chart will be appropriate to use.
X bar
X bar minus S.
X bar S chart. This is not minus. This is just hyphen. X
Okay.
bar S chart. Suppose if my sample size or subgroup size is 6, then which control chart I should use?
X bar R.
X bar R
X
chart.
bar R chart.
Where X bar is sample average, R is sample range. Suppose my subgroup size is just 1. My boss is not allowing me to make more samples. Maybe the sampling is costlier. Maybe the sampling is a destructive sampling. Or it is not possible to select more than one sample. In such scenarios, I should go for IMR chart. For example, if I want to monitor the daily sales, how many data I will get for a daily sales? Tell me.
One data.
Just only one data point. So I only have one value. What is the sales on one day? Only one data. Sales on Tuesday. So which control chart I can go for?
IMR chart.
IMR. All of you agree? Sales is a variable data, right? Sales is a variable data. The unit of measurement dollars
Sir,
or rupees.
sir, this R is coefficient, correlation coefficient.
R is range. And
Okay.
particularly in IMR chart, it is moving range.
Okay.
The difference between second data and first data. And then the difference between third and second data. Something like that you have to go. So we'll discuss everything in detail. So what I do is, see, the knowledge of control chart is widely applied in all business, right? And so you should also develop a similar knowledge. So let's see how the knowledge of control chart is used in sports. In sports, they use control chart, right? Now also World Cup is going on. So might have, and see, I'll play this video for you. So what did you notice here? What did you notice initially? Initially, it was not given out, right? So that means they developed a technology, isn't it? They developed a technology, ultra edge technology. And technology uses the data. Technology uses the data. And using the technology, they find out whether the ball has made a contact or not. If a ball is traveling in air, will it be disturbing the air? Air molecules will be disturbed, right? It will be moving up and down, yes or no?
Yes.
So this movement anyway will happen whenever ball is traveling. Whenever the bowler is bowling the ball, air molecules will be disturbed and some movement will be there. But in addition to the traveling, if the ball makes contact on the path, then what will happen? The amplitude of vibration will suddenly increase. Yes or no? And see here, by the time the ball is crossing the bat, can you see the amplitude going up?
Yes.
So this amplitude going up cannot happen if the ball do not make any contact. So by seeing the amplitude going up, the umpire could understand that the ball has made the contact, and so he reversed the decision and then declared the batsman out. All right. So the knowledge of, the concept of special cause variation is what is used in that particular technology, ultra edge technology. All of you agree? So same manner, you all can also use control chart to understand whether the variation is a special cause or not. Whenever you see a variation, yes, you will be able to understand whether it is A common cause variation or special cause variation. See, all these variation under the red color line, it is because of the normal motion of the ball. But variation going beyond the control limit, it is because of ball making contact with some other element, not just with the air. If it hits the batsman's pad, yes, some sound will come. If it hits the batsman's bat, some sound will come. If it hits the stumps, then also sound will come. Yes or no?
Yes.
So you also have a visual picture on the right side. Video is there. Now you can understand whether it is from the pad or it is from the bat or is it from the stumps, and accordingly you can take the right decision. So your decision making, can become very, very perfect if you use this understanding, right? So control chart just helps you to understand whether the variation is due to a common cause or a special cause. That's all. But how will you use this knowledge? It is up to you. Right? It is up to you. Because the special cause can be good sometimes, can be bad sometimes. If it is bad, you must try to eliminate. You must try to isolate it. You must try to isolate the factor. Suppose if it is some good result, then you must make that factor as part of your system. Isn't it? You must somehow make that factor play all the time. Suppose your sales is suddenly going up on a particular day. Definitely it's a special cause. Is it a harmful special cause or a useful? Useful, because your sales is going up. Now you talk to your sales team and find out how they boosted the sales on a particular day. Can you somehow enable them to use the same tactics and the same techniques on other days also? What will happen? Sales can improve. Yeah, sales can improve on all the days. So if the special cause is helpful, you must try to internalize. But if the special cause is harmful, let's say your product surface finish has suddenly gone down because the tool setting has changed. So hereafter, we should not allow the tool setting to change. Right? So that's how you must deal. So that depends purely on your ability to think. So basically, there are two types of variation. One is common cause variation. The other one is special cause variation. If a process is operating with only chance cause of variation, nothing but common cause variation, the process is said to be in statistical control. If a process is operating in the presence of assignable cause, then the process is said to be out of control. If a process is out of control, then sustaining the result will be difficult. If any process is operating in a way that it is statistically out of control, and sustaining the solution will be a big issue. It will not happen easily. So if you are really concerned about sustaining the solutions, establishing control is very, very important. Establishing statistical control is important. If you don't understand this logic, you are simply giving advice to people who are not interested in listening to you. Your advice is not going to make any difference. Do you understand what I'm telling? So hereafter, if you are making improvement in any process, and at the same time, if the control chart is out of control, please understand your improvement is a temporary improvement. It cannot be a permanent improvement. If you are really worried about the permanent improvement, improve the process where the control charts gives a statistical control, evidence of statistical control. So this is called stability. So only after establishing stability, you must improve on the capability, right? So stability first, then improving the capability comes next. Ensuring stability is process control. Enhancing the capability is process improvement. All of them, you can understand by looking at your control chart. How do you know whether the process is under statistical control or not? All the process will be clustered around the center. I mean, all the points will be clustered around the center, right? At least all the points will be inside the control limit. that means there is a statistical control. Similarly, if the process is under control, now you improve the process. If you improve the process, you know what will happen? The control limit will start approaching your center line. If you further improve the process, you know what will happen? The control limit will start approaching the center line. That is an improvement, isn't it? I further if I further improve my process, my control limit will move towards the center line. And my central line will start moving towards the target. If you notice all of these things happening in a control chart, that means you are improving the process. It's an evidence of improving a process. So control charts can also be used as a visual validation tools. Do you get my point? If somebody claims, they have improved a process, then it should reflect in your control chart. All right. So that way control charts can be used. So a process which is under statistical control will have what kind of variation? Can you answer this question? Come on. What kind of variation?
Common
All are
cost
correct.
variation.
All are correct.
Common
All are
cost
correct.
variation.
All
All
are
are correct.
All are
All
correct. All are correct.
So all of you are
Common
correct.
cost variation.
Whatever answer you choose, all are, everything is correct. But only if you choose the fourth one, we will be giving you mark in the exam. This is also correct. This is also correct. This is also correct. But when it comes to an exam, you should make a wise, decision. Fourth is the correct. An out of control process will always have. What is your answer here?
Special cost. Special cost.
Special
You are
cost.
correct.
Third one.
You are also
third one.
correct.
It will
Third
have
one is
both.
also correct.
Both common
First
cause
one is
and
also correct. Second one is also correct. Third
both
one is
common.
also correct. So which one can get you mark in the exam?
3.
Third one.
Both common cause and assignable cause.
So understand your requirement. Yes, 3 is the correct answer. Any process will always have common cause. If it is out of control, in addition to the common cause, it will have special cause or assignable cause. So 3 is the best answer. We can always improve a process which is statistically out of control. What is your opinion?
True, sir. True.
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 Okay. If you always improve a process which is statistically out of control, I told you the improvement will be temporary. Yes or no? So then will you always improve a process which is statistically out of control?
Oh, first stability and then
So first bring it to a state of statistical control. Right? Because improvement in the sense, we talk in terms of capability. So this is actually, not the right idea. So the statement is actually false, right? Whenever process lacks in terms of control, first you achieve the control, right? And then you can go further. So if a process is statistically out of control, then your immediate goal must be SPC, right? Otherwise, if you are very much concerned about achieving a temporary improvement, and that's you're not systematic, right? But permanent improvement, sustainable improvement, yes, you have to go in this order. Very good. So let us take an example. So what I do is I will open a Minitab, and then I'll show it in Minitab. Just a second. So Minitab is opening. So I'll give the background of this particular case study. Imagine a company is manufacturing a product. And first of all, tell me, can control chart be used only in manufacturing industry, or can we use it in service industry also?
both.
In service industry also.
Yeah. We can use it in our daily life also. You must feel the necessity to go for a control chart. That's all. If you are monitoring something, then control chart can come to help. Right? And if the data type is continuous, then your variable chart can come to help. Right? So once you understand the data type, then you know which particular control chart can come to help. Right? So suppose you want to monitor your sugar level, blood sugar level. Tell me which control chart you will use. You want to monitor your sugar level, blood sugar level.
IMR.
Yes, IMR control chart, because maybe you get only one reading out of your body every day. Suppose even if you take sample every day, how many testing you will do in a day? Only one test you do. So only one data is coming. So it is IMR chart is the best option. Now what is your goal? Every individual reading should be should be close to each other. Every day you take the reading, you expect the reading to be close to each other. And the range, if the readings are close to each other, then the difference between my today's reading and yesterday's reading will also be minimal. My range will also be under control. My individual value will also be under control. So going to a manufacturing company scenario, we are manufacturing some product, some dimensions needs to be monitored, because customer, if the dimension goes beyond the spec, customer is going to reject. So dimensional characteristics needs to be monitored and controlled. So dimensional characteristics, let's say length. Length is a variable data. And you decided to collect sample every shift. You decided to collect sample every shift. And so every shift, you are taking sample once. Only one time you are taking sample, but when you go for sample collection, you randomly select 5 samples, 5 parts. That means your sample size is 5.
Fine.
You can also call it as subgroup size. In Minitab, they call it subgroup size. So every shift you are taking 5 samples, and you wanted to understand whether the dimension, the length of the parts produced is under control or not, right? So let me now show you Minitab, because Minitab is ready now. You can see here, right? So as you all know, I gave you the Excel file also. So I'm just opening that Excel template, sigma level calculator. So I have the data file available, length. So file name is camshaft. Let me check whether camshaft is available. Where is it? Okay, coating thickness, nothing wrong. I have coating thickness. Let me take coating thickness. See here, 75 data points. And now, see here, first 3 samples taken from roll number 1.
So
That means
the screen is not moving, sir.
Okay. I'm showing Minitab, that's why. So let me show complete screen. Yeah, now you are able to see my Excel file. You see here, coating thickness. The file name is coating thickness. Here, 3 samples are taken together. See here, roll number 1 or shift number 1, 3 samples. Shift number 2, 3 samples. So every time we are taking 3. That means our sample size is 3. So I just copied this. Control C. So I'm going to Minitab. I'm just putting my cursor in the gray bar. I'm pasting it. So now data. What is the data? Data is about thickness. So thickness means it's a variable data. Right? And variable data. And what is our subgroup size?
3.
3. So what is the chart I should plot now? X
R.
bar R
X bar
chart. Very
R.
good. That's all. Very good. So now I just have to go to stat, go to control chart, go to variable chart for subgroup. In that I should choose X bar R. You can also read the subgroup. One of you, can you read it out?
Monitor the mean and the variation range of your process when you have continuous data in subgroups. Works best with subgroup size of 8 or less.
Subgroup size of 8 or less. So the same scenario we are in. So choose that. All observation in one column. I have typed all data in single column, so I choose that option only, one column. Now click here, and this is that column I should select. Now subgroup size, how much I should give subgroup size?
3.
3.
3.
Now go to X bar or option. Certain tests are recommended to understand whether the variation is special cause or common cause. At the preliminary stage, I want all of you to understand that if any point falls outside the control limit, then it is special cause. Right? So first point only I'm just ticking. You see here? This point. Point more than 3 standard deviation. Point more than 3 standard deviation means the point is falling beyond control limit. There are other conditions which you can add if you feel, adding those condition is relevant and meaningful to the current condition of the process. This is like, growing our children. When we are actually, helping the, guiding our children, what do? Initially, we put, apply certain conditions. Yes or no? As they start obeying and then following, what will you do? You'll keep on adding some more advices. Yes or no? So the same manner, this is the first one to start with. If you straight away you tell everything, they'll follow nothing. So instead of that, you add the conditions one by one. And what conditions will be relevant? It depends on your process understanding. Right? So the first condition I am giving, and later on, we'll talk about this. So select that, give OK, and then you give one more OK. Now, control chart will get plotted. Yes. And then it is giving you some red color points. All these red color points are evidence of special cause affecting your process. But what is that special cause? Who will tell you? Control chart will not tell you. Control chart can only give signals that your process is under the influence of some special cause. Special causes are normal, are considered external to your process. The factors that trigger special cause are considered external to your process. If a factor is external to your process and still that is coming and affecting, you have a job to do, isn't it? Right? So all these red color points are questioning opportunities for you. You as a manager or a leader, you must question the team why this point has fallen out. They are not only questioning opportunities, they are also opportunities for investigation. You must investigate why this has fallen out. And then try to understand whether the special cause is just whether the special cause event is a one-time event or a recurring event. If it is a one-time event, then you find out the root cause and then, correct it straight away. And finding out the root cause and correcting it will be an easy job. But if it is recurring in nature, that means, if the error is at the process level, not just a human error. Right? And so you have to investigate and then, fix it. So now there are two control chart, please note. One is range chart. The range chart seem to be under perfect control. Can you see here? The range is under perfect control. No problem with the range. The meaning of range is the variation within subgroup. Range represents what? The variation within subgroup. What is there inside your subgroup? Can one of you tell me? What is there inside your subgroup?
3 readings.
3 samples are there inside. And now you should know what these 3 samples represent. What these 3 samples represent. Suppose if you have taken one subgroup of sample every shift, this 3 is representing what?
Sample taken in one shift.
3 represents one complete shift.
Shift.
The 3 are the representative samples of all the units produced in that shift. So the variation of your parts produced within that shift is now represented by the range. Do you understand? If the range is out of control, What does it mean to you? All the unit that is produced in that particular shift is out of control. Yes or no? The variations are more. If the variations are more, then chances of bad parts entering the market and reaching the customer is very high. Is it okay for you?
No.
That is why the range must be under statistical control. If the range is not under statistical control, there is the chance of bad parts entering the market and hence reaching the end user will be very high. Then the warranty claims and so many issues will start happening. So to prevent that, we need to ensure the range is under control. This is known as within subgroup variation. All of you understand? See, within subgroup represents the variation within the shift. Why do I just change, the word from within subgroup to within shift? Because every shift I have taken, one subgroup. So depending on your data collection plan, you can interpret the meaning. Okay, your range is perfect control, no issues here. But how about the subgroup average? Now tell me, fifth subgroup, there is a problem out of control. Suppose if you are in that position, you are the shift manager in for shift number 5. Now what will you do? How will you react in this scenario? Come on, please.
We
If a
have to
point
When the
is
parts produced,
We have to hold that batch.
very good, you have to hold that batch. Don't dispatch. That is your point. All the parts produced in shift number 5 must be isolated. All the points produced in the shift must be isolated. Why? Since the average is out of control, then there is chance of more bad parts entering the market is very high. So that's the reason why you should not dispatch. You should isolate. You should quarantine. After that, what will you do after isolating the particular batch? What will you do?
Sort 100%.
Start?
Sorting 100%.
Yeah, very good. 100% inspection. Some companies go for again sampling, right? But it's better straight away go for the 100% inspection. It's a kind of punishment maybe, but anyway we have to go through since we have not maintained the process in proper control. Now we have to go for 100% inspection. The advantage is you will be able to separate the good and bad, and then the good can be dispatched and bad must be documented well so that investigation can be triggered in that direction. What kind of problem and all that investigation will happen. So, okay, you have done that. Now, what will you do with the shift number 6? Can you continue the production? Is it okay to continue the production after segregating the good and bad?
Need to find the special cause.
Very good. We need to find the special cause. If you don't find the special cause, if your process is continue to be under the influence of special cause, then the same thing can happen in shift number 6 also. You're running a big risk of allowing more bad parts to populate in the 6th shift also. If you really wanted to avoid that, you must definitely investigate. You must definitely investigate and then find out the root cause, fix it, then only you must continue with the production. Right? So now you see so many out of control scenarios. Every time a point is going beyond the control limit, every time if there is a special cause recorded, there must be an action taken report. Agreed? If there is no action taken report, but you still continue with the production, that means you are not taking any action. You are not believing in continuous improvement. You are not learning from any failures. Only God can help you. Right? So you are running such a kind of scenarios and environment. But if we say I believe in continuous improvement, then you must learn from failure. You must learn from failure, isn't it? So see so many failures. You see here 1, 2, 3, 4, 5, 6, 7, 8. Just within 25 shifts, there are 8 stoppages. Every stoppages you must learn. Right? And if the reason is found to be some kind of special cause, you must try to eliminate. Suppose if certain special causes are good for you, I think in dimensions, both sides are harmful. Over dimension is also a problem, under dimension also a problem, all are harmful. So you must eliminate everything. Suppose if it is an examination score, student scoring high mark is helpful for me. I want everybody to score more mark. So though it is a special cause, I want the special events to become a common events. So I will interact with such students. I'll ask them, how are you able to score such high marks? And then share those valuable piece of information with all the other students. Slowly, what will happen? Every student will start scoring high mark. And that's how I will make my control chart under control. Hope all of you understand what I'm telling, right? So special causes can be helpful also, can be harmful also. You can learn from both. If it is a harmful special cause, try to eliminate those factors, isolate those factors from your process. If the special causes are helpful, and those factors you must identify and make them part of your process. Internalize those things. And in return, in both cases, your control chart will become free from special cause. Clear all of you? So this is how you need to use the control chart. And once your process starts operating under perfect statistical control, then you can start applying additional conditions. Do you understand what I'm telling? Once, once the control chart is brought into a state of statistical control, what you can do is you can start applying additional conditions. Like for example, expecting attendance for all the sessions is a good thing, yes or no? Because all of you coming inside the class is very, very important. But coming inside the class alone is not enough. That is also agreeable, yes or no? Initially, I wanted everybody to be inside the class. But then my expectations started increasing. All of you should be active. All of you should be on the video. All of you should ask at least one question. These are extra conditions. Isn't it? Because after coming to your class, some students can completely sleep flat throughout the session. Possible. So you should be able to detect and then eliminate. Don't just simply believe. If all the points are inside the inside the control limit, it doesn't mean that your process can be in statistical control. There can be still something special can be happening. You need to look for trends and patterns. You need to look for trends and patterns. If there are trends, if there are patterns, yes, that could be a kind of special cause. You can try to eliminate that. So you will be learning about those extra tests in the upcoming sessions. So now you understood what is the purpose of a control chart. Any questions to me on control chart?
Yes, sir. So
What?
if there are
Yes.
one-sided tolerances, like minimum 50 kg full strength should be achieved.
Okay.
So in that case, 60 is also acceptable, 100 is also acceptable, 150 is also acceptable. So
But
and
less
it
than
would
50 is
be
unacceptable.
yes. So that
Okay.
would be a destructive testing. So in that case, which kind of control chart I would be able to use?
Okay, like you said, it's destructive testing. That means you have some limitation on the sample size.
Yes.
Yeah. So is there any specific, any requirement sample size need to be 1?
Need
Can
not
be
be,
more
but
than-
if I increase the sample size also, all the samples will not be representative of the full strength.
No. No, you have to take the sample, in a way that, they can represent your population. That is a sampling plan and sampling technique. You can plan. But sometimes, people go with the random sampling. Okay, no problem. Let's assume you take one sample only. Then in that case, you have to go for, IMR chart only. You have to go for IMR chart only. See whether your process has a two-sided tolerance or one-sided tolerance. It will definitely have variation. Variation will always be on both sides. Variation will always be upward also, downward also. So in any scenario, your control chart will have two control limit, upper control limit as well as lower control limit. All right. When you are conducting the capability study,
Sir,
that time only, the one-sided tolerance you need to apply. You will only have lower spec and no upper spec. That means you need to look at only CPK, not CP. If your process is having a one-sided tolerance, so your CP really has no meaning, but your CPK has. So that's the difference. But when it comes to the control chart, whether it's a one-sided tolerance or a two-sided tolerance, control chart will be same. You will have both upper control limit and lower control limit, and then the variations are expected to be minimal, and you should keep on reducing the variation. You can never make the variation to appear only on one side. It is not possible. Variation always be both sides, because that is the nature of normal distribution. Normal distribution is always symmetrical about the center, right? You will definitely have half of your variation on the right side and half of your variation on the left side. But you can try to control where do you want your center to be, where do you want your average to be. All that you can do. You can keep your average to the near preferred value. If the preferred value is below 50, then you keep, above 50, you keep it above 50. Right? And that's how we must deal with it. Hope I have answered your question.
Yes, sir. Why CP is insignificant, sir?
See, CP, since you said, your tolerance is only sensitive one side only. Say, for example, our exam also. If you score below 60, we are worried. You score above 60, 70, above 80, above 90, above 100. Up to 100 is possible. So we are not worried. So in this case, there is no point of calculating CP and keeping this, because CP simply compares your specification width to the process width. Let me draw something. Yeah. Seeing this is your upper spec and this is your lower spec. And your process is operating like this. Now, this is the specification width. Specification width. And this is your process width. We expect the process width to be smaller than specification width, so that the CP can be higher than 1.
Correct.
Right? But if you don't have the upper spec, you don't have an upper spec, then imagine a scenario. You only have LSL. Right? You only have LSL and you don't have any upper spec. And your process, now what happened? The specification width, you will not be able to calculate, first of all.
Correct.
You will not be able to calculate. And even if you assume something, and then if your process is staying on the left side, staying on the, you want your process, don't come to the, below the LSL, but your process can still come. And you might compare this width with some other width, and you might make a wrong conclusion. So for one-sided process, don't look at CP. CP, is meaningless. But CPK also, we always calculate two things, CP upper, CP lower, right? And now left side is the problem. So CP lower needs to be calculated, and that will be obviously be the value of CPK. So if the process is one-sided, in the capability analysis, there are some restrictions to look at only CPK and not CP. But when it comes to the control chart, you should always have both control limit and then, study it in the normal manner. It will not influence your analysis in any manner, whether the process is one-sided or two-sided, whether the customer tolerance is narrower or bigger. Customer tolerance do not come into picture at all in your control chart. Because in control chart, we are dealing with only control limit. So when the specification limit comes into picture, you are actually performing capability analysis,
Okay.
right? So yeah, perfect. So now we move on. So now, in this particular example, subgroup size was 5. So, subgroup size was 3, and that's the reason why we took X bar R chart. Suppose, just for assumption, let me say subgroup size is how many? 75. Let me say 15. Now, which control chart I should do?
X bar.
X bar, yes chart. But please note, you should never attempt to plot control chart the way I am demonstrating right now. Whatever is your sample collection strategy, the same strategy should be continued during plotting of your control chart. This is only for knowing you the Minitab path I am showing. Please understand what I am telling here. I am only assuming subgroup size is 15. But what is the actual subgroup size? 3. You can't combine 5 subgroup and then say your subgroup size is 15. This is a very, very, wrong thing. You should not do it.
Okay.
You get my point? If in your company, if you have taken, sample size of 5 at a time, and then you combine 2 sample and tell your boss, sir, sample size is 10, you are making, a kind of a poor logic it is. It is in fact a foolish idea, because that is no way going to help you.
Mixing
Right?
two data rather.
Yeah. If you want to keep your sample size 10, then you must take 10 samples at a time. By taking 5 at a time and then combining the 5, 5 cannot be a sample size of 10. Right? But now I have just only to demonstrate you, I am assuming. Now let us assume subgroup size is 15. And now in this scenario, the chart will be X bar S chart. So go to stat, go to control chart, go to variable chart for subgroup, go to X bar S. This is only to understand what? Minitab root. That's all, nothing else. So now the same coating thickness. Subgroup size, what should I do? 15. It is assumed. Please note. Assumed. And then X bar S option. Test. Initially only one test. And later on we add many tests. And now since subgroup size is 15, I will only have 5 points. See here, 1, 2, 3, 4, 5. And when the subgroup size was 3, we had too many out of control points. That is the real scenario. But this is only, just for discussion sake. If the subgroup size is 1, then what should we do? We should go for control chart, go for individual chart, IMR chart. Coating thickness. Now IMR option. Test. Again, only one test. Okay. And one more okay. You see, for all 75 points, you have individual value. I mean, moving range first, individual value. Do you understand, all of you? See, once you know what kind of control chart is ideal for monitoring your process, once you decide the more appropriate sample size, sampling frequency, sample collection period, all these pieces of information are very valuable. Yes or no? You must share all these pieces of information to the people who will be running your process. Isn't it? You should tell them, hey, you should plot this control chart. And this should be your sample size. You must take sample every hour. And then, it should become part of their daily routine. That is known as control plan. That is known as control plan. And every time a point was going out of control, you have the action taken report. You have the action taken report, and that should also be, part of your control plan. Then people, later on, if something goes wrong in the same manner, they can refer to the old scenario and, maybe the same action might be required in the future also. But not exactly, but this knowledge will be helpful. So you must keep reference of all of these things, and that is known as control plan. In the absence of which, people will not know the sample collection frequency, will not know the sample size, will not know which control chart, and then troubleshooting issues will be a big headache. Right? But you, since you are part of this particular project for more than 3 to 6 months of time, all this valuable information can be, made into a set of document known as control plan. This is what doctors will also be doing while discharging a patient. They call the patient for a counseling and give them, all these valuable advices. Because the root cause is known and the treatment given was known to the doctor. So the doctor will be advising, see, hereafter, you must avoid certain food. You must avoid, your daily routine should definitely include certain things. And these medicines have to be taken in this frequency. And doctor consultation should happen in this frequency. This is nothing but control plan. Isn't it? If the doctor don't give that particular advice, then what will happen? The patient can get into the same trouble, within a short time. And again, he has to come for the treatment. Same manner, sustaining the solution might sometime, will become difficult because of poor control plan. So you must develop a set of documents which will handhold the people, particularly the process owner, in the right direction. And whenever an out of control scenario happens, he will also deal it diplomatically like you. That is known as control plan. So the ultimate outcome of the control phase is a beautiful control plan. All right. So at what frequency data must be collected, and sample size, and what kind of control chart, and out of control scenarios, how to handle. So those are the things. So now I will just take you through the slides so that we will be able to conclude. Yes. Okay. Very easy. Yeah. So you can see my slide now. And whatever be the industry, what needs to be understood is data type. The data type is continuous and the subgroup size. Accordingly, control chart can be selected and the procedure is written here, but you don't have to worry about it because you parallelly have the Minitab and, so you don't have to plot the control chart manually with the graph sheet and other things, which are old techniques, outdated techniques, in fact. Nowadays, nobody is plotting control chart manually, right? But all the manual calculations are illustrated here. How to calculate the range, the maximum and minimum have to be identified. The difference is the range. And then see here, there are 25 subgroups. So 25 subgroup average, 25 subgroup range. These are the data to be plotted in the control chart. So first you should plot range chart. First you plot, draw the center line, upper control limit, lower control limit, then mark the values, then plot the ranges one by one. All the ranges are under control. So range is under control. Only when the range is under control, the looking at the X bar chart will have a proper meaning. When the range is out of control, it is better to avoid referring to the X bar chart. Similarly, center line, upper control limit, lower control limit. Now every point here in this control chart is an average, subgroup average. Right? All the averages have to be plotted. But the moment you see a particular point outside the control limit, some stoppage of your process is needed, quarantining the production is needed, and 100% inspection must be initiated, separation of good and bad should be carried out, and then the bad must be investigated. All right. So this is the X bar R chart. And these are the formulas. You don't have to worry. The Minitab is taking care of all these formulas you see here. right? The control limit, upper control limit, lower control limit, center line, everything is there. So this is about the summary of what we studied in the control chart. So I have explained everything, the R chart and other things. And see, like the variable chart, there is also attribute chart, right? See here, attribute chart. How many charts are there? Attribute chart? 4. P and NP. P chart, NP chart, C chart, and U chart. When to go for the attribute chart? When you are dealing with attribute data. Attribute data means you are just monitoring and then you are trying to control the defects and defectives. How many defects you made every shift, or how many parts rejected every shift. When you talk in terms of rejected parts, you are monitoring defectives. When you talk in terms of defects, you are monitoring defects, right? And for defectives, you should go for P chart. For defects, you should go for C and U. Now, what is the difference between P and NP? When your sample size is a constant, fixed sample size, then you should go for NP chart. Similarly, between C and U, when your sample size is fixed, you should go for C chart. Imagine you are an accounts officer and your team of accountant are creating invoice. And every invoice they are making some mistakes. In some invoice, the date is wrong. In some invoice, there is no signature. In some invoice, the quantity is wrong. In some invoice, the price is wrong. You are worried about the defects they are making. So you wanted to monitor the number of defects they are making every single day. Right? Now tell me which control chart you should go for. Which control chart you should go for? You are worried about the number of defects they are making, right? Every day, how many defects or how many errors they make?
Measurable.
Okay, no, which control chart here? Will you go to the attribute chart or you go for a variable chart?
Variable.
Variable means, you
Attribute.
know the meaning of variable, right? Variable means measurable. That will have a unit of measurement. You are now counting. You are now counting how many errors. Isn't it? Today, my company raised 100 invoice. And my people, in all 100 invoices, my people have made 37 mistakes. Now, 37 is the count of the defects, count of the error. So I have to refer to the defects now. Now I have two options, C chart and U chart. When to go for the C? When my sample size is fixed. If you have the habit of checking all the invoices, will you be producing same number of invoices every day?
No.
No, variable. Then you should go for U chart.
chart.
Suppose you just randomly pick 10 invoice and then do a thorough check. Now you go for C chart. Clear? So whether it is an error, mistake or a defect, C and U. Suppose if you are talking in terms of defectives, like in a bank, number of failed transactions. Number of failed transactions. There are thousands of transactions happening. But how many transactions are a failure? Failure means it's a defective, isn't it? You're not able to succeed. Now it is finally cancelled. So defectives or parts rejected. Now you come here. Defectives. And again, think about the sample size. If the sample size is fixed, you should go for NP chart. Otherwise, if it is a variable, P chart. So you can deep dive into that. And see this, I will only show the scenarios of special causes, but then this actually comes out of your experience and maturity about the process. If you learn more about your process, then you will be able to develop additional conditions. Otherwise, commenting will be discussing will be difficult. So this is definitely a special cause, and this is also considered a special cause. And not only process knowledge, your knowledge about normal distribution also plays a big role here. If your process is performing against the rule properties of normal distribution, that means your process, there is more chance that your process can be under the influence of special class. Yes or no? So that's how it is. So this is also here. The problem is there is a trend, continuously points moving up. This is also a kind of special cause. Here, points are exactly up and down, up and down, up and down, up and down. So nobody should be able to make any comment when they look at your process data. That means you are controlling your process in an excellent manner. If somebody can point fingers on you, you are making a mistake. Yes or no? So if anybody looks at the control chart, they should be clueless. That's the ultimate scenario, right? So here there are some questionable opportunities. That's why your process, is suspected to be under special cause. Here, do you see any problem here? See, these things you will be able to develop only if you recall the properties of normal distribution. Right? As the points move away from the center, the probability of the points appearing far away from the center will be very, very less. But what is happening in your process? Out of 3 points, 2 points are falling beyond your 2 sigma limit. And this is not just possible. All right. And that's why, they added. So out of experience, you will be able to definitely develop. And also you should understand more and more about normal distribution. See here, too many points clustering around the center. That is also against nature. Too many points. If all of you, suppose if the class average is 90 and all of you are scoring exactly 90 mark, and that is also leading me to a big doubt. Isn't it? So everything too much close to the target is also doubtful, but maybe good. But currently it is coming under the category of special cause. So this is again, what is this reason here? What is written here? 8 points in a row above 1 sigma. So nothing is falling close to the center line. So these are all various special causes. So control plan should typically include the process documents, data collection plan. This is where people struggle. And wherever possible, create some mistake proofing, fool proofing system, response reaction plan. If a point falls outside control limit, what are they supposed to do? Because you have come across similar scenario. If it falls on the right side, if it falls on the left side, you, to your best of your ability, you write. But finally, the scenario has to be properly understood. Then audit inspection plan. How many samples and what frequency of sampling, and the recommendations about the specific control chart, all of them together is known as a control plan. So this is a sample control plan, but then, you have to create the one for your process. And if you could understand reading out, yes, you read out. I'm not going to read it out. Right. All right. So another simple tool, Poke-OK. What is Poke-OK? It's a lean tool. It's a Japanese word meaning mistake proofing. Right. See, there is a problem here in the design of this stove. This is A, this is B. Which one is having a better design? A or B?
B.
B.
It matches the orientation. So the chance of wrong operating irrelevant knob is lesser. That is the advantage. So here, the drilling machine, the drill bit can go beyond the specified depth because there is no prevention, nothing is stopping, isn't it? Whereas here, a stopper is added. Now, whenever the driller goes beyond the specified depth, the stopper will not allow. This is a kind of mistake proofing system, right? The more the mistake proof your process is, the lesser the chances of failure. We call them, poke-yolks. Number of poke-yolks, if you just, monitor, and then if you advise your people to keep on increasing the number of poke-yolks in a particular line, slowly the failures will vanish. Right? So here, in addition to the stopper, there is also a buzzer. Right? So these are all, other real life examples of mistake proofing. See, we used to search the cables by properly tagging them with the name. Yes, you can avoid. So poke-OK can be of three types: shutdown poke-OK, control poke-OK, warning poke-OK. So what is shutdown poke-OK? If when a mistake is about to happen, the system will shut down completely. Like for example, you are using your credit card and you are putting, wrong PIN number repeatedly, more than 3 times. What will happen?
Block.
Your card will be blocked. That's a kind of shutdown poke. A feature is added in all credit cards just to ensure misuse of the cards. That's a shutdown poke. Okay. If your laptop charge is less than 10%, what will happen? It will shut down automatically. If the machine is not, all the shutters are not properly closed, then what will happen? You will not be able to.
Start.
No, yeah. Or if the machine is running and somebody suddenly opens the shutter,
Stop.
machine will stop automatically. So these are all examples of shutdown poke. Okay. Control poke. Okay means it will not allow you to proceed to the next stage. Imagine you are sitting in a car driver seat, but one of the door is not locked properly. Now you want to start the engine, the car will not allow you to start. You could see these features in all modern cars, isn't it? That's an example of control poke. Okay. But if you don't wear a seat belt, then you can see the buzzer coming. That's a kind of warning poke. Okay. Right. So more the poke-yolks in your line, in your process, the lesser the chances of failures happening. Agreed? So that's the idea. So control poke. Okay. And what is this poke? Okay. Is it warning or control? People are crossing.
Warning.
It's a
Warning.
warning. Whereas here you see some kind of
Warning,
gates,
just a
barricades.
signal, sir.
Now this is a kind of control. Very good. So it's a kind of design poke. Okay. Now what is the improvement in the design here? From the left and right, the right side, an additional drain hole is added. In the very initial stages, there were no drain hole. Only this is the option, the draining line. But in addition to that, there is one more draining line. So water spillage can be prevented. So can you see a design poke? Okay, here again another example of design poke. Okay.
Yes.
What is the advantage? The
Split
slipping
phase.
of the screwdriver can be reduced. As a result, minor accidents can be prevented. More, and then your productivity can go up. Many things, right? A small improvement, but many benefits. So you must document all the solutions and all the benefits. Why? Because what do you call, the knowledge will be available, and then sometimes you may have to replicate your solution in other areas for horizontal deployment, and for all that, the documentation is very important. So replication and then standardization, and do some sort of cost benefit analysis, how much you spent, how much savings achieved, and find out the ratio, cost to benefit, right? If you keep the cost in the numerator and benefit to the denominator, then the cost to benefit ratio must be less than 1. If you keep benefit on the numerator and cost on the denominator, then the cost to benefit ratio must be more than 1. Right? Just you see, you are now too good at documenting everything and converting everything into dollars. The man hours, if a project team 10 members are working, and throughout the project they have spent, each one have spent 120 hours. Then 10 into 120,200 man hours. Then 1 man hour, how much is the cost? So likewise, you must document everything for the man hours, then for the machineries, then for any testings done, everything should be converted into the cost, and conduct and perform a cost benefit analysis And then now all the documents have to be transferred to the process owner. And then you can also sign a document known as a project closure document, right? So a kind of project closure document. So any pending work, pending task, all that have to be marked properly and then hand over so that they can pick up from there. And once project closure is done, then some kind of reviewing how we succeeded, where and all we struggled, and that is some final meeting is always helpful, because you can evaluate yourself, you can understand the plus and minus of driving your project. And the management may also consider devising some kind of rewards. Why? Because recognizing the good work and celebrating the good work and drive operational excellence and process excellence philosophies within the organization, and managing the change becomes easier. Because if people are rewarded for the delivering results from the projects, then everybody will be motivated to take up similar challenge, and then they will also try to deliver the results. So that's it. So if there are any questions, you can ask. Otherwise, we are done with all 5 phases. So any questions to ask? Please feel free to ask.